Hello dear students, we have already discussed exercise 11.3 question number 1 to 3. Today we are going to discuss question number 4. The fourth question is, Rukshar painted the outside of a cabinet of measure 1 meter into 2 meter into 1.5 meter. How much surface area did she cover if she painted all except the bottom of the cabinet? So what is the shape of the cabinet? It is in the shape of a cuboid. And what is the volume of the cuboid? The sides or the dimension of the cuboid is, if you think of length, breadth and height. If you think length is 1 meter, breadth is 2 meter and height is 1.5 meter. This is the dimensions given. Now she has painted it from the top, only the bottom portion is not done. So we have already learned that the total surface area TSA of cuboid is equal to 2 into LB plus BH plus LH. Okay, but here total surface area minus the bottom portion. Bottom portion will be same as top portion, that is L into B. Okay, this is one way of doing. Or else if you want, you can also do the lateral surface area plus the top surface area. That is, what is LSA of cuboid? Lateral surface area is 2 into L plus B into H plus LB. So either you can use total surface area minus LB, or you can use lateral surface area plus LB. Okay, so these two ways you can do it. So I am going to use this formula. Okay, you can use any one of the formula. I am going to use this. So that is equal to 2 into L is 1 meter, B 2 meter into 1.5 meter plus LB. LB is 1 into 2. So total 2 into 3 into 1.5 plus 2. What is 1.5 into 2 is 3. 3 3s are 9 plus 2, 11 meter square. So total surface area of the painted portion or painted portion of the cuboid is 11 meter square. So the area of the painted portion is 11 meter square. Now the next question, that is question number 5 is, Daniel is painting the wall and ceiling of a cuboidal hall with length, breadth and height 15 meter, 10 meter and 7 meter respectively. From each can of paint 100 meter square of area is painted. How many cans of paint will she need to paint the room? Same type of question, that is L is equal to 15 meter, B is equal to 10 meter and H is equal to 7 meter. Here again the 4 walls and the roof is painted. Okay, so area of the 4 walls, or you can find out lateral surface area plus roof is also equal to bottom, that is equal to L into B is equal to, what is LSA? 2 into L plus B into H plus LB. Okay, so 2 into, so the area painted is equal to 2 into L is 15, B 10 into H 7 plus L 15 into 10. So total 15 plus 10, 25. So 2 into 25 into 7 plus 150. That is 50 into 7. 350 plus 150. That is 500 meters square. Now what information is given? One tin paint can cover how much area? 100 meters square. So 500 meter square is equal to 500 upon 100, that is 5 tins of paint required. So paint required is equal to 5. So how many paint packets of how many tins of paint is needed, or how many cans of paint is needed? 5 cans of paint needed. Now question number 6 is describe how the two figures at the right are alike and how they are different. Which box has larger lateral surface area? That is the question. Now see here it is a cylinder. Diameter is 7 centimeter, height is also 7 centimeter. And here it is a cube with all three sides, all the length, breadth and height 7 centimeter. So you have to find, what is the question? How the two figures at the right are alike and how they are different. From these two, which one has larger surface area? Now you saw the picture or the figures of the question you saw. Now we have to find what is the similarities and what is the difference. So what is the similarity you saw? Both the cylinder. Let us write, one is a cylinder and the other is a cube. Okay, so let us write what is the similarities and what is the difference between the two figures. See, both of them have same height. So height of cylinder is equal to 7 centimeter. Here also height is equal to 7 centimeter. So what is similar? Height are, both have same height. Both have same height. Okay. Now what is the difference? One is a cylinder. First one is cylinder. And second is a cube. Now what is one more difference? If you see, what is the other difference? The radius or the radius is 7 upon 2 and here side is equal to 7 centimeter. So these are all differences. What is the difference and what is the similarities we have to find, and also we have to find which box has larger lateral surface area. So we need to find the lateral surface area of both figure. Now what is the lateral surface area of cylinder? It is LSA, right? LSA is equal to, what is the formula? Perimeter into height. That is 2 pi r h. So that is 2 into 22 upon 7. R is 7 upon 2 and height is 7. So 7 got cancelled, 2 gets cancelled. 2 7s are 14. 2 7s are 14 plus 1, 15 centimeter square. Here LSA is equal to 4a square. 4 into, what is the LSA of a cube? It is 4a square. 4 into 7 into 7. That is 4 into 49. 9 4s are 36. 4 4s are 16 plus 3. 19 centimeter square. Another way also, 4 into 50 is 200. 200 minus 4, 196. In both the ways you can calculate. Which one has more surface area? The cube has more surface area. So the total surface area, lateral surface area of the cube is greater than LSA of cylinder. Now question number 7 is a closed cylindrical tank of radius 7 meter and height 3 meter is made from a sheet of metal. How much sheet of metal is required? So what is given here? The radius of cylinder given. Radius of cylinder is equal to 7 meter and height is equal to 3 meter. Now what is the question? If it is made up of a sheet, how much sheet is required to make that? So while learning the lateral surface area, we already learned that the lateral surface area of the cylinder will be equal to area of the rectangle which is used to make it. So what is the area of the sheet? Area of the sheet. But here one thing you have to think is it is a closed cylinder. So here a closed cylindrical tank. Closed cylinder means you have to find out both the top and bottom portion also. So we need to find total surface area. Area of the sheet is equal to TSA of cylinder. If it is an hollow cylinder, then it will be LSA. But here it is a closed cylinder. Closed cylinder means something like this. This is a closed cylinder. Here also closed, here also closed, and this is curved surface. It is a closed cylinder example. So if I have to find out how much plastic is used here, I need to find this area and this area. Okay. So what is TSA of cylinder? 2 pi r into r plus h. So it is 2 into pi is 22 upon 7, r is 7 and again 7 plus 3. That is equal to, see, 7 got cancelled, 44 into 10, that is equal to 440 meter square. So area of the sheet is 440 meter square. Now question number 8, the lateral surface area of a hollow cylinder is 4224 centimeter square. It is cut along its height and formed a rectangular sheet of width 33 centimeter. Find the perimeter of the rectangular shape. It is similar to this question but with a different. Here it is a hollow cylinder. Previously it was a closed cylinder and both the end area we have to, end faces we have to count. But here it is a lateral surface area is given. So LSA of cylinder is equal to area of rectangular sheet. Area of the rectangular sheet is equal to LSA of the cylinder. Now let us write all details. What all things are given here? It is directly given 4224 centimeter square. And in area of rectangle we know that it is equal to L into B. But they have given you width is already given. Okay. B is equal to, width means breadth, is equal to 33 centimeter. This is given. Okay. And you have to find out L. Length of the sheet is equal to, how will you find out? If you know the area and you know the length, how do you find out? Is equal to LB upon L, which is equal to 4224 it is. 4224 224 divided by 33. Now if you check, you see 4 plus 2 6, 4 plus 2 6, it is divisible by 11. So let us divide. Here 11 into 3, 33. What is remaining here? 9. 90 to 8 times. Then 4 times. So here 3 into 11. So both 11s get cancelled. Now check whether it is divisible by 3 or not. 3 plus 4, 7. 7 plus 8, 15. Okay, 8 plus 4, 12 plus 3, 15. So 384 upon 3. Which is equal to 3 ones are 3, 3 12s are 36, 24, 3 8s are 24. So what is the length of the sheet? Length of the sheet is equal to length of sheet is equal to 128 centimeter. Now question number 9. A road roller takes 750 complete revolution to move once over to a level road. Find the area of the road if the diameter of the road roller is 84 centimeter and length is 1 meter. Now see, if you imagine that this is a road roller, just imagine. So I am marking one point here. Okay, now if it starts from here, this point, I am keeping it here. Now if it rotates or roll, it start rolling. Where is it? Okay, I'll mark it again here. Okay, take this as the marking point. Let us take this point as the marker. Okay, so I'm keeping it here. Now if I keep it here and I rotate it till that point comes on the paper again. See, it comes till this. So what will be this equal to? This is the distance, right? This distance between these 2 points will be equal to what it is? This. What is this? Lateral surface area. And now road roller you all might have seen. What is the shape of it? It is cylindrical. Okay. So distance travelled. Distance travelled or covered in one rotation is equal to LSA of cylinder. Did you understand? Yes. Now, what is the LSA not given? What else is given in the question? Find the area of the road if the diameter of road roller is 84. The diameter, that is D is given, is 84 centimeter. And the length means this distance. Okay. Here the length is 1 meter. So for the cylinder it will be height. Okay. Length or height is equal to 1 meter. Now to find the lateral surface area. LSA is equal to, what is LSA? 2 pi r h. Okay, that is equal to 2 into 22 upon 7 r. Here diameter is given. So how will you find r? R is equal to d upon 2. 84 upon 2, that is 42 centimeter. So here 42. H is 1 meter given. So we have to convert it into centimeter. That is 100 centimeter. Now cancellation, 7 6 are. So when you multiply 22 2s are 44 into 600. See, 4 6 are 24. 6 4s are 24 plus 2, 26. This many centimeter square. This is the lateral surface area. Okay. Now the road roller takes 750 complete revolutions. Okay. One revolution is this much. One revolution is equal to this much. So total how many revolutions it is taking? 750 revolutions is equal to 750 multiplied by 26400 centimeter square. So when you multiply, we will get, when we multiply these two, we get this number. What is the number? See. 1, 10, 100, 1000, 10,000, lakh, 10 lakh, crore. 1 crore, 98 lakhs, like that. So now to convert them into meter square, how will you convert? 1 meter, 100 centimeters. So 100 into 100, because it is centimeter square to meter square. So 2 zeros cancel, here 2 zero cancel. What do you get? 1980 meter square. So in 750 revolutions, how many meters it will cover? The area covered by area, how will you write the step? Area covered in 750 revolutions is equal to 1980 meters square. Now the last question, that is question number 10 in that chapter, in that exercise, is question number 10. Let us read the question. It is, a company packages its milk powder in cylindrical containers whose base has a diameter of 14 centimeter and height 20 centimeter. Company places a label around the surface of the container, and if the label is placed 2 centimeter from top and bottom, what is the area of the label? Now again we can take this as example. Okay, if you take this as example, you imagine this length is 20 centimeter and this diameter is 14 centimeter. What they have done here and here, they have left the same distance. Here it is little different, but here if you remove the cap and think, okay, if you consider this much, here and here they have kept a 2 centimeter gap. So you are asked to find out the length or the area of what is the area of this label. Okay, so for that this height is given 20 centimeter. From that, here also 2 centimeter, here also 2 centimeter. So total how many centimeters to be removed? 2 plus 2, 4 centimeter to remove. So what will be the height of this paper? The height will be equal to 20 minus 2 plus 2, that is 20 minus 4, 16 centimeter. And length of this paper, what will be the length of this paper? Equal to, here it is not completed. So if you think complete paper, if you think, what will be the length of this paper? This, what is this called? This is the perimeter of the circle, right? So the perimeter of the circle, that is 2 pi r, will be the length of the paper, and the height of the paper will be how much? It is 20 minus 2 into 2. So let us write, what is the height of the cylinder or height of the cylindrical container, right? So you can write the steps like this. Height of container is 20 centimeter. So height of paper, or you can consider a height of paper, or it can be considered as breadth of paper. Is equal to 20 minus 2 plus 2. Why 2 plus 2? 20 its original height, cylinder height. On the top and bottom, this 2 plus 2. 2 and 2 to be left without covering. So what is the total breadth of the paper? 20 minus 4, which is equal to 16 centimeter. Now the length of the paper, length of paper is equal to circumference of base. What is the circumference of base? It is 2 pi r. Okay, it is equal to 2 pi r. So how to find 2 pi r here? Radius is diameter is given. Okay, given diameter is equal to 14 centimeter. So what is radius? 14 upon 2, that is 7 centimeter. Now how to find 2 pi r? 2 pi r is equal to 2 into 22 upon 7 into 7. That is 44 centimeter. So you got the length of paper is equal to 44 centimeter. Breadth of paper is equal to 16 centimeter. Therefore, what you are asked to find out? Area of the paper, or area of paper or label. Okay, is equal to 44 into 16. L into B. 16 fours are 64. 16 fours are 64 plus 6, 70. 100 centimeter square. So what is the area of the label? Area of the label is 704 centimeter square. With this question, exercise number 11.3 gets over. In the next class, we will discuss about volume of the solids. That's all for today. Thank you.